Hello students, let's see the another program in Xilinx, that is your shift register. So already this code we have saved in VHDL. So first you have to go open project. So you have to select the file. So already we have written this code in Xilinx. So you have to select the name and you can open it. So here by default you are getting the library. Then this is the code for entity. So this code is for your universal shift register. So universal shift register means what? The register which can do all the operation, that is right shift, left shift, parallel loading and all. Okay. So in the one code you have to show the parallel loading, right shift, left shift and hold operation. So that's why first you have to take the 4-bit data. Okay. So this is a 4-bit shift register. So you have to take D in as a data bit and that is your 4-bit. So you have to mention as, you have to select the bus in the entity. So you will get the code here as a 3 down to 0. Then now this shift register comes in your sequential circuits. So clock signal is must. Okay. And always you require the reset signal to remove your previous memory. So clock and reset signal are the additional here as comparative to your combinational circuit. Okay. So here directly you can give the clock as a input signal and that is your single bit. So STD underscore logic. Then reset signal you have to take here, that is again a single bit. So RST in STD underscore logic. Then you require the output line. So again it is a 4-bit shift registers. So you require the 4 output lines, that is your D0 is your 3 down to 0. But please take precaution that your D0 that is your output pins means it is a 4-bit. So output of the first flip-flop will go to the clock input of the or it is go to the input of your second flip-flop. So that's why that D0 bit you have to take as a input and output port. So here you have to select the port as in out. Okay, please remember this. And again to select the operation you require the selection lines. Okay, so it is a 2-bit selection line we have considered. So S is your input and it is a 2-bit means 1 down to 0. So by using the bus you can give the number of bits. Okay, so this is the end entity. Now let's see for the architecture. Here this code we are written by using the behavioral modeling style. So here your architecture name is behavioral of your entity name. Okay, so now here you have to use the signal. So already you know the what is the difference between the signal and the variable. Always your signal is declared before the begin and after the architecture. So here you have to declare the two signal, that is your MSB bin and the LSB bin, and you have to just give the type of that signal. So it is a STD underscore logic. Then you have to go with begin. Again it is a behavioral modeling style, means you have to go with the process statement. So inside a process block you have to declare your sensitivity list. So under a sensitivity list, this is your universal shift register is a sequential circuit. So your whole operation is depend on the clock signal. Okay, so when you apply the clock signal, only that time you can change in the output. Okay, so that's why clock and the reset will come under the sensitivity list. Okay, then you have to go for the begin. Now whatever the data already stored in the shift register, first you have to remove it. So that's why you have to just take the reset signal. Here we are consider reset as a active high. Okay, so that's why here we are consider if reset is equal to 1, then your output will be 0 0 0. Okay, it is a 4-bit, so it is output as 0 0. Now else if means here your reset signal is deactivated. If reset is not 1, then what is the condition? So that's why here we are taken else if. After that you have to apply the clock. Okay, so clock tick event and clock is equal to 1. So after a reset signal, here you are applying the clock signal. Okay, now then if you are applying the clock, first you have to, it will accept your MSB bin to your D in 3. Okay, means your D in 3 bit is assigned to your signal MSB in. Okay, same as your D in 0 is assigned to signal LSB in. Okay, so now this code again we are written it by using the case statement. So this is case S is. So again we have consider your selection lines code as 00. Means it is a 2-bit. Okay, so when 00 D0 is assigned D0, means what is the meaning of this? Whatever data input or whatever the last data stored in the D0, same you will get at the output. Okay, so this is simple operation, you can say as it is a hold operation. Okay, so now when selection line code is 01, then your D0 bit is assigned as MSB in, and it is a D0 of 3 down to 1. So it will select your MSB bit and it will just give to your your D0 inputs. Okay, so now it will do the write operation. So when you give the first clock signal, your first MSB bit will become as a 1. Okay, not exactly 1, whatever data you give to the D in, according to that, whatever the MSB bit, it will accept that value. And again if you give the clock signal, it will just shift it to the right. Again if you give the clock signal, it will again shift to the right. So this second statement just it will perform the write operation. Okay, now let's see, if your selection line code is 10, then D0, now D0 is assigned as 2 down to 0 and LSB in. Okay, so same again, whatever your D in data, it will select the LSB bit from that data and it will just start to shifting to the left. Okay, so your third statement will do the left shift operation. Okay, so now let's see the last one, that is when 11, then D0 is assigned as D in. Okay, means if you make a change in the D in, automatically you will get change in the D0. So it will just do the parallel operation, or it is a parallel loading. So in the same code we had seen, there is a hold operation, there is a right shifting, left shifting, and the your parallel loading. Okay, and if here we are using the case statement, so always other statement is must. So when others, D0 is assigned as 00, means if other than this selection line code is there, your output will be 000. Then again you have to end the case. Now here we are use the if statement. So first you have to end if, and then all statements are enclosed in a process. So again you have to end the process. And last one, you have to end the architecture. So you have to end architecture name as your behavioral. Okay, now here your code is ready. Now you have to go for the simulation. So again here you will get the option as behavioral check syntax. Okay, so here you have to select this one. So here you will get the option in the below, that is behavioral check syntax completed successfully. So that's why you have to go for the simulation part. So again it's running now. We are selected as a simulate behavioral model. Okay, it's opening now. Okay, so whatever the input output ports we are selected here, all options you are getting it here. So first one is your data in. So first you have to force the value for the data in. So again it is a 4-bit. So here we are selected as 1 0 0 0. Apply. Okay. Now here you have to give the clock signal. So again you have to go for the clock. Okay, so you have to go you have to just make a right click where you will get the option as a, instead of force constant, you have to go for the force clock. Okay, so in the force clock there is, you will get this window. So first you have to just put a value for the leading edge value 1, trailing edge 0. So this is either negative edge or positive edge. You can just change that value, and again you can just mention the period for your clock cycle, that is a 1 microsecond. We have selected here, apply. Okay. Okay, so first as per our code, there is an instruction as if reset is equal to 1, your D0 should be 0, 0. So first we'll apply the reset as 1 and let's check for the answer. Apply, okay. Okay, so if your reset is 1, here we are not selected any selection line code. Simply by giving the reset option as a 1, you will get D out as a 0. Okay. Now, after that, you have to first deactivate that reset. So, force constant 0, because in the code we are written as else if statement, means if your reset is not 1. Okay. So, that's why you have to give reset as 0. Okay, then you have to give the selection line code. So first we'll just give the value as 0, 0. Now it is a 2-bit. Apply, okay. Now we'll run. Okay, now let's see. Okay, now here you can check. This is your MSB bit and LSB bins are assigned here. Okay, so in the code, in the data in, we are taken as 1000. So that's why MSB bit is assigned as 1 and LSB in is assigned as 0. Okay, and your selection line code is 00, your D0 is 000. Okay, so it is your hold operation. Okay, now we'll change the value. So 0, 1. So again run. Okay, now let's see. Here this is a, if selection line code is 0, 1, you are getting 100, means it will select the MSB bit is 1. That 1 is added to your final output 00. So that is 1 is added here. So 100. If I select, again I select the clock, I am getting the next option as 1100. If again I am running it, again I am getting 1110. So that 1 is shifted to the right. Again for next cycle I am getting the option as 1111. Okay. So MSB bit 1 is shifted to the right. Okay. It will do the right operation. Now we'll change the selection line code. So it is 10. Okay. Now run it. Now let's see. Our final answer is 111. Yes, our D0 is 111. Okay, here. So if we select the selection line code as 10, it will just select the LSB value. LSB value is 0 from the data in. Okay, and that is added to your final answer. So it is started from the left side. So 1110. Again, if I run it, 1100. Again I run it, I am getting 1000, means 0 is shifted from the left. 0 is shifted from the left and final answer I am getting as 000. Okay, so it will just do the left operation. Now we'll go for the last operation, that is 1111. So for the 11, again if we run it for the 11, so for 11, please go in a code for 11. Yes, in the 11, it will do the parallel loading operation. So whatever your data, same you will get at the output side. Okay, so please let's check. 100. I am getting the option as 100. My data in is 100. Same I am getting at the output side. Okay. So students, here you understood for hold operation, right shift, left shift and parallel loading. Let's see our RTL schematic. Okay, please wait. Synthesis. Here you will get the option as Vivo RTL schematic. Okay, you have to select the project, add, create schematic. Okay, let's see, this is your diagram is created here, where we have applied the input as D in as a 4-bit data, S is your 2-bit, your